Hello, here are a bunch of arc length integration questions. In fact, all of them that have been asked in the past couple of years, we're going to go through them and get an idea of how they like to ask these questions. So we know that generally for arc length, if we're given some position function r of t and some bounds on t, the arc length of the curve on those bounds is going to be the integral, in this case from 1 to 2, so just between the bounds, of the square root of the derivatives of each component squared. So what do I mean by that? Well, we can find an r prime of t, which in this case will be 2t, 1 over t, and then we can square all those components and add them together and put that all in this square root here. We'll get 4 plus 4t squared plus 1 over t squared dt. And this looks a little scary, and this whole integral right now looks pretty scary because, we still have everything under a square root, but in every case, you will be able to simplify down if it's something in this form, where it looks like it could be factored and simplified. Yeah, it can be. So in this case, we can use 2t plus 1 over t squared. Because if we FOIL this out, we're going to get 4t squared plus 4, because the t's will cancel, plus 1 over t squared. And so now our integral has gone from very scary to not scary at all, because now it's just t squared plus ln t evaluated on 1 to 2. This will be 4 plus ln 2, and this will be 1 plus 0. So 3 plus ln 2 is our answer. Okay, this is one of the more tricky ones. We have to find length of the curve from 0 to pi, and they're giving us an identity to use, and pretty much whenever they suggest that you use an identity, that identity is pretty necessary for solving it, because otherwise we're going to end up with a pretty scary thing to integrate. So let's find our r prime of t and find the magnitudes that we need for our square root. R prime of t is going to be 1 minus cosine t, comma, sine t. And so our big square root expression is going to be 1 minus 2 cosine t plus cosine squared t plus sine squared t dt, and this is all from 0 to pi. Well, we can simplify this down right off the bat. Cosine squared t plus sine squared t is going to be 1. We can combine our 1's and get a plus 2. But now what do? We've got a negative cosine t under a square root, which looks pretty bad. But we can use this identity up here. Where you'll go wrong is seeing this identity and thinking, oh, we don't have a cosine of 2 anything. Well, actually, we do have cosine of 2 something. We have 2 t over 2's in here. So all we need to do, we can replace negative 2 cosine t with negative 2 1 minus 2 sine squared t over 2. So I hope you can see how that identity can work. That identity works no matter if it's a 2 or a 1 you're dealing with. It can also be just a 1 and a 1/2, as long as you're using the same ratio in between there. So now let's replace this in here. This is, well, we don't want to forget our 2. 2 minus 2 plus 4 sine squared t over 2. And now this gets much simpler, much faster, because our 2's will cancel. And then we have a square in here that we can take the square root of, and we're going to have the integral from 0 to pi of 2 sine t over 2 dt, which is going to be the same thing as negative 4 cosine of t over 2 evaluated on 0 to pi. Well, at pi, cosine of pi over 2 is going to be 0. And at 0, the cosine of 0 is going to be 1. This will be negative 4, so our answer is 4. Okay, a much more simple one. We can do this one really quick. Our r prime of t is going to be 3t squared, root 6t, and 1. And so our big square root expression is going to be 9t to the 4th plus 6t squared plus 1. So let's see what we can do with this. Well, this is just going to simplify down to the square root of 3t squared plus 1 squared. And so we can simplify and set up our integral from negative 1 to 1 of 3t squared plus 1 dt, because both of these guys, our square and our square root, will cancel. This will be t cubed plus t evaluated on negative 1 to 1, which will be 2. That will be 0. Oh, sorry. Let's make sure we're right about that. Negative 1 cubed is negative 1, minus 1 is negative 2. Our answer is 4. Okay, a little bit of a different way of asking the same question. They're giving us a position function for t is greater than or equal to 0, and they want the x-coordinate of the particle after it has traveled a distance of 2 units. So let's figure this out. Really, this is going to be the integral from 0 to some value a of everything else that we normally do. So r prime of t is going to be 5 minus 3 and 4. And if we square everything in there, we're going to get root 50 in our integrand dt. Okay, so we want to solve for this a here. So this will be root 50t evaluated on 0 to a. And we want this to give us 2. Well, 0 is not going to contribute at all, so really we're solving for 50a. Root 50a equals 2, which is a over 2 root 50. And one of these answers should be equivalent to 2 over root 50. We just have to figure out which, because we can simplify this root 50 down. So root 50 is going to be 5 times 5 times 2. So we can replace this with 5 root 2. And now all you have to recognize is that this is a t value. This is not our x-coordinate that they're asking us to solve for. We know that the x-coordinate is given by 5t. So if this is equal to t, this a value is equal to t, then 5 times 2 over 5 root 2 is just going to give us 2 over root 2. Multiply both sides by root 2, and we will get 2 root 2 over 2, or just root 2. Okay, a particle has this acceleration and this initial velocity, and we need to find the distance traveled. So we know it's really the velocity expression that we're looking for, because we're starting off with r of t, which is our position function, and we are differentiating to get to our r prime of t, which is the same as v of t. And so really all we have to do here is solve this first part of this kind of particle motion question to get the velocity expression that we need to solve the rest of it. So we know that in order to go down this chain, we have to differentiate, and we're starting with acceleration, so we know we're going to have to integrate to get back up. So this the integral of a of t, each component will be 0 plus c t squared plus c root 2t plus c. And then we have to match up these c's with our initial value here. So we know that we want our x component to be 1, so c has to be equal to 1, so this whole component is 1. And then both of our other ones we need to be 0 for t is equal to 0, so both of these c's are 0. So there's our velocity expression, and now all we have to do is do the rest pretty normally. So we're going to have the integral from 0 to 3, those are the bounds that they give us, of the square root of 1 squared plus t to the 4th plus 2t squared, which we can simplify down to t squared plus 1 squared, or at least inside our square root. That's what we can simplify down to, which will cancel out with our square root, and we'll get the integral from 0 to 3 of t squared plus 1 dt, which is t cubed over 3 plus t on 0 to 3, which will give us 12. Okay, we're finding the length of this curve on these bounds. This shouldn't be too bad. We need an r prime of t, which is going to be 4 cosine of t, 3, and 4 sine of t. And then setting up our square root, this will be 16 cosine squared t, no comma, plus 9 plus 16 sine squared t. And this will all simplify down to the square root of 25, which we can integrate on 0 to 1/2 dt. And we will get, the square root of 25 is just 5, which we can integrate, and we will get 2.5. Okay, finally, another pretty standard arc length question. We need an r prime of t, which is going to be 2t, 1 over t, and we can find our big square root. This will be 4 plus 4t squared plus 1 over t squared. Well, we've seen this exact thing before. This will just be equivalent, this entire expression, to the square root of 2t plus 1 over t squared. And this will simplify down to 2t plus 1 over t integral from 1 to 2 dt. Well, this is just going to be t squared plus ln t evaluated on 1 to 2. This will give us 1. This will give us 4 plus ln 2. And these are, I'm relatively sure, let me go check, that these are from different tests. It's exactly the same problem, 2 different exams. So maybe one of the other ones that has come up will come up on our final. That would be pretty nice. Okay, and finally, it's another one where we're told that the particle has gone a distance of some value, and we're finding the x coordinate. So let's find our r prime of t. That's just going to be 2, -2, and 1. Well, the magnitude of this is just going to be the square root of 4 plus 4 plus 1, or just 3. And we're integrating from 0 to a dt, and we're saying that that's equal to 3. So solving 3a equals 3, this is just a equals 1, and we remember that a is really the t value for which this is true. So when t is equal to 1, when t is equal to 1, the x component is 2t. For t is equal to 1, that will be 2. Okay, I hope that was helpful for some people, and thanks for tuning in.